Hello and welcome everyone to this Mirantis Labs Tech Talk. Today's Tech Talk is about Kubeflow, with the title Orchestrating AI Workloads on Kubernetes. I'm your host today, Julian Hennig, Senior Solutions Architect working at Mirantis for around 2 years now. If you want, feel free to reach out to me or connect on social media. Or check out what I'm doing on GitHub. I'll introduce you today to machine learning and Kubeflow. We will look into what is machine learning, why is it relevant for AI or with AI, what is Kubeflow, how does it work, how does Kubeflow work. We will look into an example implementation of Kubeflow. And we'll also have a brief look into how it looks like. So a quick demo of Kubeflow and where it can help. Let's start with artificial intelligence and machine learning. Of course, this talk is more about machine learning and machine learning ops. So we will look into what machine learning is, first of all, to understand how it is beneficial to artificial intelligence and where it helps when it comes to the technical challenges. What is machine learning? First of all, we need to explain some words which we'll use also in the demo and in the explanation on what Kubeflow is. Let's start with a model. So a model in machine learning is essentially mathematical relationship that is derived from historical data. So this model is what the machine learning or the machine learning system uses to make predictions or decisions without being explicitly programmed to perform the task. When it comes to the types of learnings, the difference for different learning types, like, for example, the supervised learning, like it's already named supervised, so either system is supervised by humans, in the sense that we provide with labeled data, or in other words, the correct answer to a problem. It's like teaching a child by showing examples what is the correct answer or what is right. Then there's the supervised learning. Unlikely supervised learning, the data here is unlabeled. So the machine learning system tries to identify patterns and clusters in the data on its own. So it's currently looking all the time into the data and predicts what can be classified or clustered. Then there's the reinforcement learning, which is the type that uses rewards. So rewards or penalties based on actions it performs. So it's similar to teaching a pet tricks through rewards or gentle nudges, for example. There are different applications, and these are not the only ones, but some of them are listed here. For example, regression. So regression is a scenario where you get, at the end of the day, you get a numerical value. So, for example, the ETA, the estimated time of arrival for a journey. Then there's classification. Classification can be further divided into binary, so yes or no answers, or multi-class classification. So, for example, email spam filters often use binary classification to find spam or any phishing emails. And then there's generative AI. So generative AI is an exciting frontier where the model generates new content based on the input it receives. Most of you already know ChatGPT, so that is a classical generative AI application or in machine learning. So this application can be text to image, but also text to code, or image to code, or a lot of different things can be done with generative AI. Like, for example, with DALL-E, on the right, you can see I've tried to create an illustration. Of course, my prompt was not the best, but my prompt was data to decision pipeline illustration, sorry. And at the end, I got something that's not really accurate and is not helping at all. But I thought, of course, putting that into this presentation too, because it all depends on how we talk to the AI, how we talk to the machine learning, of course, models too, and how we train them. Then we get to three more words like data sets. So a data set is essentially a collection of individual examples. Each example contains features which are characteristics or attributes. So this can be, an example for this can be if you sell a house, for example, a feature could be the number of bedrooms or locations or square footage, while the label would be actual price of the house. When we talk about training the model, it's always trained using this data set, where the features are the input and the labels are what we aim for the model to predict accurately. So this is usually done in supervised learning context, where the model tries to understand the relationship between the feature and the label. We've already talked about supervised learning, so that is where we say what is the correct answer. And then we have another term, which is inference. So after the model is trained, it's time for inference, which is the process of making predictions. So if you look on the right, we have a data set, we have a labeled example, and we give that to the model, and the model is creating predictions on the actual right values, the right labels. And it's taking these unlabeled examples where we don't have the answer, and predicts the labels based on the pattern it learned during the training phase. When we go into the connection between those terms, there's something that can describe it very well, which is the model development lifecycle, where you have training on the left side and inference on the right side. So it's about training the model. So it gets trained, it gets tuned by us. So to say, for example, it's the right answer, we give it more labeled data. Then it goes to the inference, so it gets served to the actual user. It gets monitored, and based on our tuning, it gets updated again. And data ETL is extract, transform, and load. So at the end, of course, we need to give that model a better understanding of what is wrong and what is right. When we look into the system, and basically now I'm referring to Kubernetes already, it gets very complex. Because if you think about all the different tasks I've just mentioned in the last 3 slides, you can see here what is actually needed. So the model in this example, or in this illustration, you can see is just a very tiny bit. It is the most important one, of course, but it's a very tiny bit. So think about the model like the LLM from Meta. So the LLM that is open source, I think it's called Llama 2, it's just a model. So it's just one small part. And for all the different tasks around that model, you need to have different parts in that system. For example, if we start with the gray area, it's resource management, of course, Kubernetes, resource management, of course, configuration. We have to look into automation of the whole system. We need to have a look into monitoring of that system to make decisions again on just the infrastructure. Then we have the inner part, which is metadata management. We have the process management. So different tasks, of course, needs to be managed or orchestrated. We have serving the infrastructure. Of course, every time we do training, we need some kind of infrastructure. In our case, with Kubernetes, it is pods. We need to have some kind of model training. Data verification, we need to check if the data is correct. We need to have something for data collection, so databases or some kind of system that does provide the collections of that data. And of course, the model debugger, that is the most near component next to the model. Normally, for all of those different tasks, you need to have different people to look into those things. Like a machine learning engineer needs to look into serving the infrastructure. He needs to provide monitoring, but also have parts of the resource management, metadata management, and automation. The same for the data engineer that is providing the configuration, automation, looks into data, looks into how we can use that data, how we can do feature extraction. Remember, features or attributes. So feature extraction, data verification, and of course, there's part resource management and metadata management to provide something to the data scientist, who's actually responsible for all the rest. So model analysis, model debugging, the model itself, and process management, and access to metadata management. So a lot of different parts, and you will see when we talk about Kubeflow more directly, it gets as complex as mentioned earlier. So machine learning ops at the end is nothing else than the extension of machine learning to DevOps. So if you think about machine learning, of course, you need to have some kind of iteration that can be added to the DevOps cycle. For machine learning ops, there are a lot of different tools. So the Cloud Native Computing Foundation is expanding very fast, especially the Linux Foundation for AI and Data. So there are a lot of different tools and a lot to talk about. But today we'll focus on Kubeflow. And next to Kubeflow, there is the alternative MLflow, but there are differences. There are like pros and cons. It's a big debate. What is better? What is for which use case? We will, first of all, today look into Kubeflow. So start with that one, but we will go into different topics in the next talks as well. So let's go into Kubeflow and have a look into what Kubeflow is. So it's an open source platform for machine learning. We've already talked about machine learning or MLOps and about all the workflows or all the different integrations into the different components. It is designed for Kubernetes and designed to make deployments of machine learning much simpler, portable, and scalable. It includes different tools, many different tools. We'll have a look into those two in the next slide. And it's developed by Google, but contributed to the CNCF. The first release was in 2018, And it is now incubating project since just a few months. So from July or since July 25th. When we look into Kubeflow, we have many different components. So let's start with the infrastructure. You need to have, of course, some kind of infrastructure. Either it's cloud or you have on-premises or you have anything that can provide CPU, TPU, and GPU. On top of that, we have the layer of Kubernetes, of course, for orchestrating everything that needs to run. Then we have Istio, which is the component for traffic routing. So every time you go, for example, into a specific notebook where you want to run your machine learning tests, that's again something where Istio needs to look into. And of course, it can scale very fast. So we need to have something that scales with it. We have Knative. So Knative is an event manager. It does event handling and helps to build, deploy, and manage modern serverless workloads. So in simple terms, it deals with the logistics. So your code only runs when it needs to, saving you resources. Then we have a lot of other components on top of that. On the left side, we start with the Kubeflow Central Dashboard. So the Kubeflow Central Dashboard is the monitoring and management dashboard for Kubeflow. We have the TensorFlow and PyTorch operator, which both are training operators. We'll look into that in our demo. We have Kserve for management, workflow management. We have Knative for hyper parameter tuning. And we have pipelines, which is the workflow management, Kserve is the model serving part. So many different components that offer pre-processing, prediction, post-processing, and explain of machine learning data. When we look into Kubeflow with, for example, K0s, it looks pretty simple, but of course it will be and can be very complex. When we start with the infrastructure, we can, for example, integrate with CUDA, and have a partnership directly with NVIDIA, so it's possible to use GPUs out of the box with K0s. We have K0s, which is the Kubernetes distribution. It also runs a lot of other companies already. We have the essential components. Those essential components are for the Kubernetes cluster itself, can be Prometheus, Grafana, but also Argo, for example. So you can have a GitOps approach even for machine learning. We have Istio. Istio, of course, can be complex. So we have Tetrate as a partner, and we have DEX. DEX is another simple solution, but it can be very complex in this regards because of multi-tenancy and multi-users. That's something we will talk in another tech talk too, about too. We have the data components for data collection, for example. If you think back on the slide on the who's who in machine learning, or we can provide support with Portworx as a partner, and the actual machine learning parts too. Of course, Kubeflow, Knative, and everything can be installed with Kustomize. Kustomize can be very complex, and for that, I've created a Git repository that you can use to get at least K0s up and running and all the components that are needed for using Kubeflow. Demo time means we will have a look, or can have a look, into, first of all, Lens, which makes it simple now for me to show you what is actually happening. When I use Kustomize to install all the components, it's a simple command to install a lot of objects. that are needed. And you can see the custom resource definitions here. There are a lot: Knative, Kserve. Can actually have a look into those definitions. So for DAX, we have components. For Kubeflow itself, we have components. For networking, for Istio, for Kserve, for Knative. So for a lot of different components. The same we can see here in the pods. So of course, actually, this one is not relevant, but you can see the central dashboard for Kubeflow. You can see the machine learning pipelines and a lot more components that are needed. As soon as you've just used Kustomize to bring everything up, we can do port forwarding. So what I just did is I've used port forwarding for the Istio ingress gateway. And Istio can be, again, also very complex in this regards because of the different CIDs. What I did is just use a port forwarding for the Istio ingress gateway on port 80 and on my local port here in my browser. With that, I can browse the component, the central UI component, and as a user, userexample.com, I can just browse through Kubeflow here directly and look into what happened, what is going on in my cluster. And as a machine learning, even as a machine learning engineer, I can look into what is running currently in this namespace, but also in other namespaces. So when it comes to multi-tenancy and multi-user isolation, Kubeflow uses namespaces for this isolation. You can specify who should see what and who can get access to what. So that's up to your configuration, the configuration you're applying. When it comes to machine learning, of course, we can use very simple Visual Studio Code to run a very simple, again, for a machine learning script. So let's just use Visual Studio Code. We can specify the RAM, we can specify the CPUs, we can even specify GPUs if we have one. In this case, we have one. So we can create new volumes. We can use existing volumes, of course, too. That's possible, or create other volumes on different other storage providers too. In our case, we just use 10 gigabytes, will be a local path. So that is already a storage class from Kubernetes. So I've installed very simple cluster on one node. And this is the local path provisioner. I can specify the home path, but that's all good. Let's launch this notebook. What is now happening in the background is if we just go back to our lens to our cluster, and we have a look into the namespace, we can see that there's something starting. In this case, we do not have enough GPUs. So let's get back to this one, delete it, and create a new notebook. So I don't specify any GPU, and just launch it. Oh, already exists. Let's launch that notebook and jump back into Lens. And we can see that there's a new container that is ready. So I can go back to Kubeflow. I can see it's ready, status ready. I can directly connect to it. And that's where all the magic happens from Istio in the background. So now I have direct access to my notebook server. which is essentially a pod in the background. So that's all automated out of the box. And I can, of course, not only use Jupyter, I can use others too. I can use custom notebooks here as well if I want to, and just add more custom images in here too, specify what I need. So we'll just call it test, launch that. Test volume already exists. Yeah, I already did that. Test 2. And now we can see its type is Jupyter notebook. And I can, as soon as it started, I can launch this notebook, get again a very simple redirect into that container and use it for machine learning or for my machine learning Python script, for example. Of course, that's just a very high level view. I know, and it's just the UI of Kubeflow. We've skipped the installation steps. So that is something that we will cover in another session where we will go into how to install it. I will provide the GitHub link anyway, so you can check and test my code that I've provided too. But we will look more in detail into this, how to install something. So I can do whatever I want here with now my Python script. I can add folders. So a machine learning or data scientist can already do his job as long as he has access to the data or to the data sets you want to use for the machine learning. That was just, as mentioned, a quick demonstration of Kubeflow. It can get very complex, as mentioned earlier, but it already simplifies all of that. So if we look into the different components in here, everything, of course, interacts with each other. So you need to have proper network management and a proper connection in between your cluster nodes. And if that is working, there's no big harm. But configuring something or customizing something, of course, needs to be well planned. As a summary, we've looked into the machine learning and artificial intelligence fundamentals, very high level fundamentals, into models, into data sets, training, and inference. We looked or talked about what types of machine learnings there are, like supervised learnings, very simple, where we give the machine learning or the actual processes the correct answers, so labeled data. There's the unsupervised learning, which is just looking into classification, for example, or patterns. There's the reinforcement learning, where we give different help or nudges to the machine learning model and reinforce the learning to make it better. Don't remember the word I was used to say, or I wanted to say. We looked into the different Kubeflow components for the traffic routing, for Istio, for example, the event handling. We looked into model serving as well. So many different components that needs to be configured correctly and looked into. We had a brief look into what else there is, but of course, Kubeflow is already a CNCF project, an incubating project. So Kubeflow makes sense to allow consistency, to allow portability and scalability. And the big picture, of course, when it comes to streamlining AI machine workflows, you can, of course, use many different other tools. But with Kubeflow, you can build something on your own infrastructure, very simple, with Kustomize if you know what you're doing. Of course, there are experts like Mirantis to help with that. But it offers, as mentioned, streamlined AI and machine learning workloads. I've already mentioned that, but I want to say that again. We will discover more Kubeflow content and more deep dive content. So this was just an introduction, but we will go into the depth of Istio, DEX, for example, into all the different components and into how to set up Istio, how to set up Kubeflow in a couple of different workshops and tutorials. All the content will be published, or at least the sessions announced very early, but published date is currently planned for November and December. So feel free to have a look into mirantis.com/labs to check out new content, or have a look into github.com into our repository, Mirantis-Labs, to check out if there are new repositories or new content there as well. You can just subscribe and see all the different updates we are publishing in this GitHub repository. There are two upcoming tech talks. I've already mentioned one of them. The next tech talk will be about Ceph and Rook, so automating Kubernetes storage. Again, something that could be leveraged by Kubeflow as well, which will be presented on September 19 from my colleague Peter Roslunskowski. He's senior software engineer at Mirantis. And another tech talk about single sign-on with using DEX. So something that is very fitting into the picture of Kubeflow, where we will go into how to set up, for example, OpenID Connect with DEX, so you can do single sign-on into your Kubernetes cluster with ease, or with your Azure Active Directory, Okta, or whatever you are using. This one will be presented by Martin Nether, solution architect at Mirantis, on October the 3rd. We can do this very interactively. So if you have specific questions, we can do a quick deep dive if you want to. Where can I get the installation steps for Kubeflow? They are available online, but as mentioned, it can be a bit overwhelming. That's why we've created this repository, which I will just push today too. So you can install K8s cluster with these and use Kubeflow or use the installation steps I've provided here too to install Kubeflow. So you just need to have Kustomize to install Kubeflow. And then just go into the directory and we'll browse to all the different components here, as you can see. So profiles, Jupyter notebooks. So there are a lot of customization files and actual different CIDs and everything that is needed here too to get things up and running. So with this, should be easy to get everything, at least simple K8s cluster up and running with Kubeflow installed. Of course, what's always important is to have, if you don't want to use K8s, if you want to use K3s or another, like minikube, for example, you need to have at least or enough resources, and you need to have some kind of storage backend that provides storage. In my case, it was enough to have just local path provisioner, but of course can be anything else. The Kubeflow on minikube might be a bit problematic because of the missing resources. But there is something that's called minikubeflow, which can be installed or can be used to install minikube and Kubeflow. So this is directly accessible on the Kubeflow docs. So you can just browse the docs and have a look for minikube here. Thank you, everyone who listened in, and thank you for your patience. Feel free to like and subscribe, as one would say on YouTube. Have a look into the GitHub repository. I will upload the different artifacts and the things that are needed to get Kubeflow up and running. So thank you, and have a nice day, evening, or morning.